Lesson 13.4 is on inverse trig functions. So get excited. We use our inverse trig functions to kind of help us work backwards through what we've been doing in 13.3. In 13.3 you had to figure out what is the sine of 30 degrees, and you got 1/2. And you did it all without a calculator, and you guys are masters at this now. So 13.4, what you're going to do is you're not going to be given the angle, but you'll be given the trig value. So what is sine of theta, or what is theta when the sine of theta will equal 1/2? So the thing that's going to be a little bit tricky about this is there's more than one right answer. There actually is an infinite number of possible values we could have for theta, where the sine of that angle would equal 1/2. For example, if you were to grab your calculator, sine of 130 degrees is 1/2, sine of 150 is 1/2, sine of 510 is 1/2. Basically, any angle, if this is 30 degrees right here, that's kind of sloppy, any angle that lands there, so any coterminal angle with 30 degrees will have the same sine value. Also, because the sine is a positive 1/2, remember sine corresponds to your y values. Y is positive in this quadrant, and your y values are also positive in this quadrant. So if I have an angle over here, where this reference angle is that 30 degrees, any angle that lands over here will also have the same sine value. So that 150 degrees that I wrote down, that's right here. And the sine of 150 degrees is also a positive 1/2. So what we're going to have to do is we're going to have to restrict what quadrants we want to use for our possible answers, just so that we don't have a million possible answers that we could use. So we're going to go through each trig function. Here's our sine function. First thing you want to do, well, here's what the notation looks like. You have this -1. And so, something might say evaluate, and we say the inverse sine of 1/2. That's what the last problem looked like. And so our goal is we have to figure out what theta equals. So let's start by just rewriting it so that it kind of makes sense. We rewrite sine of theta equals that trig value. So this would be sine of theta, just like what we had in the last one, equals 1/2. And so what is theta? So we've got kind of this fancy notation over here. We're going to restrict our sine functions to be in the first quadrant and the fourth quadrant. Really what I do is I remember this visual over here, where I know that if it's an inverse sine, my angle's either in the first quadrant or it's in the fourth quadrant. And the reason why these two quadrants are picked is all of your sine values are positive in that first quadrant. So I know that these are positive sine values because that's like your y's. Now if you're down here with your y values, those are negative. So we'll catch all of our negative trig values down there. So depending on if this is a positive or negative value, we can, make some educated guesses or kind of know where to start a problem to know what quadrant it goes into. We have to go ahead and restrict the cosine function as well. So again, you're just going to start this by rewriting your inverse trig. So cosine of theta equals whatever number. We want a quadrant of positive cosines and a quadrant of negative cosines. Remember, cosines correspond to your x values. Well, your first quadrant is where your cosines are positive, and your second quadrant is where the cosines are negative. So we are going to pick angles that fall in those two quadrants. So that's the visual. If it's an inverse cosine, draw this little picture knowing that your angle has to be over here or it has to be over here. And last, let's figure out the restrictions on the tangent function. Again, you're just going to rewrite it, and we need positive and negative tangent values. So this one, remember tangent, when we're talking in terms of x's and y's, tangent is equal to y over x. Well, in the first quadrant, you have positive y values and positive x values. So a positive divided by a positive will be positive tangent. So here's where your positive tangent values will be. In the fourth quadrant, you have a negative y value because we're going down like this, but your x's are positive, so that negative divided by positive will give you negative tangent values. So if we stick to the first and the fourth quadrants, we'll catch all of our positives and all of our negative tangent values. And if you remember when we went through the unit circle, when you guys did that first quadrant, and then you kept using those same trig values over and over and over, those ordered pairs, just some were positive, some were negative. So same idea, we know it's all the same trig values going all the way around, so let's just restrict it to 2 quadrants so that there's just one right answer that we're all looking for. So there's a lot of kind of ways or exceptions to this. Don't freak out, but there are, I think, 5 examples on how to do a problem like this. Let me just show you one to explain it a little bit more, but then definitely run through those other videos because, you know, I wanted to make sure that you got a lot of different examples so that if you saw something that was a little bit weird, hopefully you saw a video on it. So if we have to evaluate inverse sine of root 3 over 2, again, this is without a calculator. This will be on the no calculator portion of your test. We start by rewriting this. We're going to say sine of theta equals root 3 over 2. And so first thing I do is I think about, well, it's an inverse sine. That means that this has to come from the first or the fourth quadrant. It's going to be in one of those two. And then the other thing I'll say is, and this is, pay attention to this idea because I don't know that I talk about this too much in the other videos. Because this is a positive trig value, I can really predict that my angle is going to be in the first quadrant because here are your positive sine values, here are your negative sine values. So I think that my angle is somewhere here. Now that's what I just drew is not accurate. I don't know what angle it is, but I know that it's going to come from a 30, 60, 90 or a 45, 45, 90. So what we think about is we go back to SOHCAHTOA. And we can kind of intuitively guess and check our way through this. If you're doing SOHCAHTOA, we know that sine is equal to the opposite over the hypotenuse. So if I look at these triangles, I'm looking for my opposite side to be a root 3. Well, I only have one triangle that even has a root 3 in it. So let me go here. If I look at the 30 degrees, opposite of 30 is 1, and I'm looking for the opposite to be root 3. So that says, let me look at a 60 degree angle. Opposite of 60 is root 3, hypotenuse 2. So I think we're dealing with a 60 degree angle. So I'm going to go ahead and say this is a 60 degree angle. Draw this down. I'll fill in all the info. Opposite of the 60 degree is a root 3. Hypotenuse is 2. Opposite of the 30 is 1. These will all be, positive 1 because we're going to the right, positive root 3 because we're going up. And just to check, is the sine of 60 degrees root 3 over 2? Well, opposite is root 3, hypotenuse is 2. So I think that we found it. Theta is going to be that 60 degree angle. And then also give your answer in radians. So to get this answer in radians, think about how many 60 degrees fit into 180 because we just want one of those. And 60 fits in 3 times, so we're going to say pi over 3. And there's our angle. So that's kind of the way we approach it. Definitely watch the videos. I have one other idea that I want to go through here on the intro. And then you should be good to go. Alright, this one actually, there's a video for this. Let me just talk about what the setup will look like and then we'll keep moving on. So you don't have to write it down. Watch the video to put that example in your notes. So this is one where you can use a calculator, find the measure of the angle in degrees and radians. Here's our angle right here. We are given the opposite side as well as the hypotenuse. So opposite and hypotenuse, that's using the SO. So we know that sine of our angle is equal to 3 over 5. Now if we want to figure out what theta is, this is when you use that inverse sine button on your calculator. So we'll do inverse sine of 3/5, and that will be equal to theta, and that's how we'll figure out what theta is. You do want to make sure, well, I guess it says both. You would do this in degree mode, and then if it's also asking for radians, just switch your calculator over to radian mode and type in the exact same thing. Alright, here's our last idea for this video, and I actually did not have concept videos on this idea. Maybe I can make some to put in there for you guys to review later, but definitely for tonight when you watch the other concept videos, this is not in there, so put this in your notes for sure. Like you're putting everything else in your notes, I'm sure, right? Okay. So we have to solve the equation for theta rounding to 3 decimal places. We know that the tangent of theta is 5.3. So we're going to go to our calculator first and do inverse tangent of 5.3 and figure out what theta is. And when you type that into your calculator, you get 79.3 degrees. We'll just go ahead and say 79 degrees. Alright, so I guess I should have started out by saying that there's something else we know about our angle that we're trying to find, and that's this information. They're going to tell you what quadrant your angle lies in. So here is a coordinate plane. If the angle's between 180 and 270, that means that it has to lie in this quadrant. Well, if you notice, our calculator did not give us an angle that's between 180 and 270. It told us 79 degrees. And where's the 79 degrees? 79 degrees is about there. That's 79 degrees. So, how can we get an angle that's between 180 degrees and 270 degrees that will give us the same trig value of 5.3? Well, if you think about, we're going to treat this 79 degrees as a reference angle, because reference angles give us the same trig values. So because you are 79 degrees off the x-axis here, we're going to go 79 degrees off the x-axis here. And this angle where this lands is going to be what we're looking for. So remember, the angle actually starts over here at the positive x-axis. It goes around 180 degrees and then another 79 degrees. So 180 plus that 79 will give us the angle that we are looking for. And we get 259 degrees. 259 degrees is between 180 and 270, so that's good. And then you can also do a check on these. You know that tangent of theta should equal 5.3. So if you do tangent of 259, check to see, do you actually get a 5.3? And I just did a quick check on my calculator. I think I got maybe a 5.1. That small difference is because I rounded back here. If I had used more decimals, I would have gotten much closer to the 5.3. All right, let's look at one more example just to make sure that this seems okay. This next one, we know that sine of theta is equal to 0.24. So, and we also know that the angle is between 90 degrees and 180. So, let's just smooth this up a little bit, get that out of our way. If I think about where that is, here's 90 to 180. It's going to be in that quadrant. And next step is, let's go to the calculator and figure out what theta could be. So we're going to say inverse sine of 0.24 is equal to theta. So when you put that into your calculator, you get 13.9, but we'll just go ahead and round it to 14 degrees. As far as the rounding that I'm doing here, just see if, you know, what the directions say. If they say round to 1 decimal place or 2 or nearest whole degree. I'm just doing nearest whole degree just to keep it easy to show you guys right now. Well, 14 degrees is what our calculator tells us theta should be. 14 degrees is not, however, in the quadrant that theta needs to be. So if we go ahead and just draw, here's where our 14 degree angle is. That's now going to be a reference angle. So I'm going to go into the quadrant that we're looking for, and I'm going to go off the x-axis 14 degrees. And that is where our angle will be located, right here. So how do we get that angle measure? I can visually see it. I know it starts over here, it goes all the way over this far. So you're always going to have to be a little bit intuitive with the math that you're doing. In this case, I would say if we take the full 180 and subtract out the 14, that will give us the angle measure that we are looking for. So theta is 166 degrees, which quick check is between 90 and 180. And another quick check on your calculator, you might as well just double check. If you do the sine of 166, do you get 13.9, or no, sorry, 0.24. And just a quick check right now, I'm doing 166, sine of 166, and I get a 0.24 or 19, blah, blah, blah. So I know that it worked out. And that's all we have for 13.4 and chapter 13. Woohoo! So the other videos obviously will not be this long. Run through them, step up your game, do what you can for this next test. Don't cut corners on any of this stuff, and let's see how it turns out.